Are you still awake? Okay. We are ready for the next talk on the main stage. I am here together with Benedikt, who will tell us about Trixnity, a multi-platform SDK for Matrix. And I will just hand over to you. You have the stage.
Thank you. Okay, let's start. Who am I? I'm Benedikt. I'm a privacy and IT security enthusiast, and I have nearly 5 years of development and admin experience in Matrix. And my first steps I made with app services in Matrix with Java Spring Boot, and that evolved to Trixnity. I'm the maintainer of Trixnity. At the moment, it's mostly me alone, so if you have time and look for a cool open source project, here's one. And I'm one of the founders of Connect2X, and we are developing Timmy, a TI messenger for the medical sector in Germany, and we are hiring. So if you want to get paid, if you are working with Trixnity or Trixnity Messenger, then come to us. Yeah, what is Trixnity? Trixnity is a Matrix SDK, and it's multi-capable. That means you can use it in clients, in bots, in app services, and also for server development or everything in between. For example, a server proxy. For example, we used it to implement a TI messenger proxy, which sits in front of a Synapse and proxies some stuff with the rule engine. Yeah, and Trixnity is multi-platform. That means you can run it on the JVM, so the Java world, on JS in the browser, or on Node.js if you want, on native platforms like iOS, but also on Linux if you want to as binary. And soon we will add WebAssembly support, which can also run in the browser or on a server. All these features we get with Kotlin. And we also have a high test coverage. We have integration tests that test the SDK with the Synapse, and we have a few thousand unit tests. The license is Apache 2, so everyone can use it, contribute it, and that's the website that we launched a few months ago with some more documentation than in a README of the repository. Yeah, the question is why another SDK? We've had so many SDKs, JS SDK, Rust SDK, but back in January 2020, when I began to implement stuff with Matrix, there were only a few multi-platform SDKs to choose from. There was the Dart SDK, and in the early beginning, also the Rust SDK, but they didn't fulfill my needs. Because mostly there is no strict typing, for example, in the JavaScript SDK, but that is more because of the language JavaScript, not the reason why the SDK is der Grund dafür. And the extensibility is difficult. So if you want to have custom events and you also want them typed, then you have got problems. And every SDK has a unique purpose, one for client development, one for server development, one for bot development, and so on. And I wanted to have one SDK for everything, so you can build on Matrix with one tool and not with 3 different tools. And why Kotlin? Because it is statically typed programming language. It compiles to many platforms. You have common code between the platforms, but you can also have platform-specific implementations. So if you are very on low level and want to implement some crypto stuff, you can use the crypto implementation of the target. So in the browser, for example, JS Crypto, or on iOS, Crypto Core, on the JVM, the crypto stuff. And you have access to it from Kotlin. You don't have to switch the programming language. You write in one language, have access to native API, and so on. And you can use libraries of these platforms. So you have access to Maven libraries, to NPM libraries, to C libraries, and can use them from Kotlin, as said. And Kotlin allows you to create your own DSLs, but I come later to it, why it can help. Yeah. Let's start with the architecture. We have the core layer. And in the core layer, there is all the modeling and typing stuff for all the event types that are specified in the matrix specification, and how it is serialized, deserialized, and so on, and some basic stuff that is important for a matrix SDK. Yeah, and this core layer allows you to add custom events. So for example, here I added a m.room.cat event, and cat event content is the Kotlin type. So you have typing when you use this event content in your SDK. You don't have to look into JSON objects. You have IDE completion, and you can be sure that the event contains that is typed. On top of the core, we have the 3 different APIs that the matrix spec defines. The client-server API, the server-server API, and the application-server API. And each API is split into 3 modules. We have the model module, where we have all the typing again for all the endpoints. So a create room, for example, a leave room. We have a request that is typed. We have the endpoint that is typed. And in the response, in this case, it is unit. It gives an empty JSON. But this is implemented in the model. So you can use it on client and on server. You don't have to implement it twice. And that looks like this on the client side. If you use the low-level API without abstraction, you can create these leave room Kotlin object and say, hey, send this request, and you get a response with the correct type. And same on the low-level server side. When you find an endpoint, which type you need, and can handle the request and response with the Kotlin object, and you get a Kotlin object, and so on. But to make it a bit easier, there is also a high-level implementation, though, so you can call rooms API client.leaveRoom with some parameters, or you implement on the server an interface. So you don't have to remember which endpoints are there. You have to implement the whole interface, the whole API. Then we have all the crypto stuff. There is crypto core on the low level. We have wrappers for libOlm, the C library, and on top of that, some higher level crypto stuff for decryption, encryption, and so on. And the crypto core uses native implementation for random, AES, CTR, HMAC, and so on. And these use really native implementations. So we don't have one common library like OpenSSL for all platforms. We use the existing implementation on each platform. And yeah, the Trixnity ORM with the libOlm wrapper in Kotlin via JNA, JS via WASM, and native via C interop features of Kotlin. We package the libOlm libraries, so you don't have to manage or build the libOlm library. It comes with the SDK. And it is long planned and on a to-do list, but very on the end of the to-do list, we want to migrate to Vodo-Semak, and started already by implementing bindings for UniFFI. UniFFI is the tool that the Rust SDK also uses to create bindings for other languages, and yeah, I also implemented a UniFFI binding for Kotlin Multiplatform, but the JS support is not there, so it's paused this project. And as also said, Trixnity Crypto uses key management, encryption, decryption of events. Yeah, not so important. Yeah, yet now come the interesting stuff. A bit higher level, we have Trixnity client, and this is an implementation where all the high-level stuff is happening. So room list is created, a timeline is created, a matrix client with repositories, media store, and all that stuff that you have to manage to create a client and to load a client, to sync to the server, save stuff to the database, and so on. And it contains most of the features of Matrix 1.7. We have an exchangeable database, an exchangeable media store. It has an extremely fast reactive cache on top of the database. E2E is included. Everything is reactive, notification, thumbnail generation, and so on and so on. So a very wide SDK, we implement many features. As I said, we have exchangeable media stores. That means you can define where the media is saved. So mostly it uses a file system on desktop. On Android, on iOS, you save the file you receive and you load the file to show it to the user. But for JS, we need IndexedDB because there is no file system. And for testing, we also have in memory. Now I came to the cache and how I accidentally created it. The challenge when we started was we want to have a UI with reactive data. So when a username changes, we want that the UA sees this change. Also when the timeline event is redacted or edited or a reaction is added to a timeline event, we want all this reactive stuff to the UI. But the problem, we don't want to stick to one database. We want this exchangeable. But not all databases implement some listeners, so you get also changes that were made from another part of the application. For example, if a new event comes from the sync, you have to find a way how you can propagate this change to the UI. And the solution was to create an intermediate layer based on Kotlin flows. And so if you read a value from the database, from the UI, so the UI says, give me this timeline event, then you get a flow. And the flow is an abstraction of changing values. So you get a starting value, and over the time, you get a change. And these flow can also be, oh sorry, Faden verloren. Sorry. If the sync writes changes to the database, it looks into the cache. Is there someone who listens to this flow? And if so, then propagate these changes into the flow. And if you are calling flows very often, you don't want to make a database call every time because this is not very performant. So if you're switching to rooms, you don't want that the timeline is every time loaded from the database, hundreds of events in worst case. So we keep the values for a bit for 10 seconds or 30 seconds in memory. So if you access the same value in the cache, you get the value that is also already there. Yeah, that's the cache, sorry. Yeah, as said, everything is reactive. we have flows everywhere, so you can get all users and get a flow of room users. You can check if you have the right to invite a user. There's also a flow with the Boolean, because it can happen that you don't have the power in the next moment to invite someone because the power levels has changed. And this is for all the APIs in Trixnity, and there are many. These are only some examples. And this cache is on top of the database layer, and this database layer, because we have this reactive cache that is listening to changes that are also written to it, we can also exchange the database. And we have a lot of them. We have an SQL-based database via Xpost. You can use SQLite or H2 or Postgres if you want on a client. Why? But this is only for JVM-based targets. You can use Realm via Realm Kotlin. There you get also iOS, for example. And for JS, we have IndexedDB, and we have a community contribution for Android X Room that uses SQLite under the hood. And for testing also in memory. Yeah. Then Trixnity does things anders als andere SDKs, es tut mir leid. Differently than other SDKs. Other SDKs and clients use the fragments they get from the sync. So if you sync events from the server, you get a bunch of events, 10 to 20, and you save them as chunk to the database. And when the next sync comes, you link these chunks together. And there may also be a gap, because the time has... there was a time gap. So you have also a timeline event gap if there were many messages. And in Trixnity, we have another approach. Each timeline event links to the next and the before timeline event. So in fact, this is also a flow. So not a flow as a time changing value, but a flow as a location changing value. So if you get the flow of the timeline of a room, you get T0, T1, T2, T3, and so on. And gaps are filled on the fly. So you don't have to worry about that you need to fetch. This is done by the flow under the hood and lazily. So only if you request the next event of the flow, then a database call or a cache call or a request to the server is done. And this helps to link upgraded rooms. So if you are using Trixnity, you don't see room upgrades because they are linked invisible. So if you start from T3 and scroll back in your client, the timelines are merged because it is one flow that is just evolving to its start to the create event content of room 1 in this case, because room 2 has a link to room 1 and so on. Yeah, here you see the DSL, the domain-specific language. This is not very helpful if you implement a client, but if you implement a bot or something, then you have a very readable DSL to react to timeline, to events. So in this example, we can send the text pong and reply to the timeline event that sent ping. And there are also reactions or redactions and so on. There are many projects using Trixnity, and these are the ones I know about. I also know there are some commercial projects that using Trixnity, but they don't seem to be, they don't want to talk about it, I don't know. There is a Spotify control bot. You can send events to start your music, stop your music. There's the Mensa bot. Mensa is a German word, I think. Yeah, and many others. And there's also Timmy. That's what Michael presented back there. But this is not open source, so I leave it for now. And yeah, the coolest thing, also a community contribution I saw the last few weeks was Smorg. And Smorg is the messenger implementation using Trixnity from Konstantin. It is also multi-platform. It runs on desktop, on Android, and on iOS, and on web. Everything is Kotlin. Nearly 99% of the code UI is UI code is with the framework written in with the framework Compose Multiplatform. And yeah, I have a little demo. This is the web version, the Android version, and the desktop version. And yeah, you can open large rooms on every client. The web version is very experimental because Compose Multiplatform web is not alpha or beta yet, but it works and it's very fast, I think. Yeah, I'm proud of it because it's the first open source messenger project built on Trixnity. It has cross-signing and all that stuff. It's in very early stage, but a good example how to use Trixnity and how easy it is to use Trixnity. Yeah, one more thing. You saw that was the architecture I showed before, and today we released Trixnity Messenger as open source project. And this is an SDK on top of Trixnity, which exposes view models for use. So you even have to do the low-level stuff like evaluating a flow and a timeline flow. You just get a view model and you say, okay, I want 10 elements or 20 elements and so on, or I'm scrolling up, or I want to delete this message and so on. This is all done in a view model that you can implement. The routing is included, so at the end, you only need a very, very thin UI layer where you make your UI, where you call Trixnity Messenger if you click a button and ask Trixnity Messenger for new values. Yeah, it's AGPL, it's open source for now, from now on, and have fun. I hope we see a messenger soon using Trixnity Messenger. Thank you very much. Contact us for questions.
Congratulations for open sourcing Trixnity Messenger.
Thank you.
Yeah, applause. I guess we have some time for questions right now. So if there are any questions in the room, I'm happy to hand over the mic. The crowd is baffled.
Sorry for the gap in the middle.
You have a question, perfect.
Hi, Benedikt. Thank you very much for the talk. We, in the company, in Econo, we are trying to build an embedded web client for Matrix. Do you think it would be a good case for using a Trixnity SDK and the things around Trixnity?
Sure, you can use it. It depends on the tools you are using. If you're using Kotlin, it's very easy. If you are using JavaScript, you need some little bindings and JS export, but it is also possible, yes. I think Trixnity Messenger would be a good start because it is an abstraction on top of Trixnity client, and you need less knowledge about the low-level matrix stuff if you're using Trixnity Messenger.
Okay, thank you very much.
Hello. if I understood correctly, you implemented some native cryptographic primitives like SHA-256, AES. Why did you went that way?
The last sentence?
Why did you decide to do it? Implementation of native cryptographic primitives.
Because we needed to decrypt some stuff and do cross-signing.
Why not use existing?
What would be an existing OpenSSL, or?
I'm not sure.
Yeah, we could have used OpenSSL for all targets, but I'm not sure if it is possible to use it in the web. It was just easier because if you use, for example, OpenSSL, you have to ship the binary, and this is make a larger package, and some other things like you have to update it, and so on.
Okay, thank you.
Actually, we ship it for Linux and Windows targets, the OpenSSL, but it is statically linked in the SDK, so no external library.
Okay. I have a question, actually. You just said you open source Trixnity Messenger. Is it also available as a binary? Is it on the Play Store? Is it on the App Store? Is it on F-Droid? Is it on the Windows Store?
You can see Trixnity Messenger as a headless messenger.
Ah.
Because it's also a SDK and it has no UI. You have to build the UI.
Okay.
The UI is, for example, Timmy, our product in Connect2X. Yeah, as said, maybe there is someone that wants to implement this tiny layer on top of Trixnity Messenger, and then we have a messenger using Trixnity that is open source.
Awesome. More questions? Let me look quickly at the Matrix room. If you're on stream, please remember, if you have questions, to go to the Matrix room general for the Matrix Community Summit and post your questions for any talks on this stage.
Thanks for the talk as well, and I also think like the general structure looks super smart. Like I really like what you presented, and I was wondering, with all the tricks like using native implementation for the encryption stuff, for example, how big a binary would be? Like not a binary, just the binary part from the SDK. Of course, the thin UI layer, of course, is a couple of megabytes as well. But
I heard from someone in an issue of Trixnity that for iOS it's 27 megabyte, but I'm not sure why it's so large. They are also not sure if it is Trixnity or if there is another library. Yeah, we have to find out, but on the JVM we have on Android, Timmy is around 100 megabyte large, but Compose alone uses 30 megabyte because they ship Skiko, that's the rendering library for Canvas. Yeah.
But in generally, this sounds like there's a quite large discrepancy for what target you build. Is that correct?
Yeah.
Okay. Yeah. Yes, that's expected.
It depends on the target. Yes. For example, on Windows and Linux, OpenSSL is shipped as well, and this adds a few megabyte, I think.
Okay, am I missing anybody else? Last call for questions. If not, I would say thank you, Benedikt, for presenting Trixnity.